Hello everyone and welcome to a new session for Computer Science 1. Today we are going to go over chapter 5, which is loops and files. Chapter 5, we're gonna go over the increment and decrement operators. We are also going to go over the while loop, the do while loop, the for loop. We are going to show an example about keeping a running total. And finally, we're gonna speak about nested loops. And after we are done with loops, we're gonna speak about file or files operations, basic. Because in chapter 12, we speak about advanced files operations. So files operations. Yeah, let's go ahead. So first thing we want to speak about is the decrement and increment operators. So the concept behind the decrement and increment operators is that those operators add or subtract one to their operands. So remember, if I have a variable called num, for example, and I say num equals num plus 1 semicolon. So I'm basically adding 1 to the variable num. Here in this statement, I'm saying I would like the variable num to be equal to whatever in variable num already plus 1. So once this statement executes, the value that was inside num was incremented, got incremented. This statement here is equivalent to saying num plus equal 1. These two statements are equivalent. So with the increment operator, I can do what's equivalent as such. Num plus plus. When I say num plus plus, the value inside num will be incremented. 1 will be added to the value inside num. Eventually, num is an integer or a short or um, any digit value or digit data type, and 1 will be added to whatever value is already in num. This is for increment. Now, on the other hand, I can do something like this. Num equals num minus 1. So this statement here will decrement 1 or will subtract 1 from the value inside num. This statement is equivalent to saying num minus equals 1. This will also subtract 1 from the value num. Similar fashion, this statement will decrement 1 from value num. So let's see it in code. Here I have Visual Studio. I'm going to say I need integer, my variable, for example, equals 10. And then if I say my variable plus plus, and then I display my var, notice that the value of my variable is going to become 11. Excuse me. So notice the value is 11. Similar fashion when I do decrement operator. the value will become 9. This is the concept behind these operators. Now you need to pay attention about the difference between postfix and the prefix. There is a prefix mode and the postfix mode. The prefix mode is having the operator before the variable. So here, this mode is postfix because post means after. So postfix, the operator comes after the variable. So the variable comes first and then the operator comes next. So this mode is postfix mode. Also here, this is postfix. Postfix. And then I have a prefix. Prefix is basically having the operator first and then the variable. Plus plus num. Now, when I do these two on a single statement, like here on this statement, notice this is a statement because I have a semicolon before it and a semicolon after it. So this operator is the only thing in this statement. This statement has only this operator. In this case, it doesn't matter. There is no difference between postfix or prefix. So notice when I do this, it showed 9. And when I also do it as prefix, will show 9 as well. So there is no difference. In this case, there is no difference. Whenever you have a statement where the operator is the only thing on this statement, then it doesn't matter if a postfix or prefix, both will serve the same um, purpose. The difference kicks in when you have on a single statement other than that operator. For example, here I'm displaying. So notice I'm gonna add the operator. And here I added it as prefix. Prefix means pre. So the operator comes before the variable. Prefix. Notice when I execute, it is 9. Now, if I do postfix and I execute, it is 10, so it did not increment. What happened here is in prefix, whenever we have a prefix, the operator kicks in first and then the statement executes. In a postfix, like here, the statement executes first and then the operator kicks in. So if I come here and after this operator, display my var, I'm gonna execute with the F10, means one statement at a time. One statement at a time. My var is 10. And now I'm about to execute this cout statement, which have already a postfix decrement. So notice when I execute this statement, 10 will be displayed on the screen. So the operator did not kick in. However, after this statement has been executed, now if I hover my mouse on my variable, it is 9. So what happened is the statement used the value that is inside my var as is first. And once the statement was done executing, it decremented value in my var. So notice now my var is 9. So when I display, it is 9. Similar to the increment. So notice with the increment, since it's postfix, it will use the value as is first, and after the statement is done, it will increment its value. So now that it displayed 10, the old value, it incremented my var. So the next statement showed the new value of my var. Similar to when you see it in functions, when you pass a variable to a function, if you pass it in a prefix, it will pass, it will increment first and then pass the new value to the function. And if you pass it as postfix, means pass the existing value as is and then increment its value. So you need to pay attention for these two differences. So I'm gonna type them here. You have a prefix and you have postfix. So prefix means, if let's say we are speaking about increment, in case of increment, in a prefix, we're gonna say increment, then use the new value. This is what basically happens. In a prefix, meaning plus, plus, num. In a prefix, whenever we have this in a statement, if it's the only operator in that statement, then no difference. But if we have this in a cout statement, for example, it will increment the value of num first, and then it will use the new value of num inside the statement. In the case of postfix, so postfix, it will use the current value first and then increment. So these are the differences, and it's the same for increment and decrement. It's either before the variable and or after the variable. As a student, there was a nice thing that I maintained in order to remember. Basically, I look at the statement from left to right. Any statement, whenever I have a operator, I look at the statement from left to right. Which one comes first? Is the variable comes first or the operator comes first? If the variable comes first, that means use the value as is and then increment, because the variable came first. So it will use the value as is first, and after it's done, it will increment. However, on the case of prefix, again, I look from left to right. So when I reach the operator, which part do I reach first? Do I reach the operator first or the variable first? The fact that I reach the operator first, that means increment first and then use the new value in the statement. So this is the difference between postfix and the prefix mode. Then we start with introduction to loops. What is a loop first? Let's go and define what's a loop. So a loop is part of a program that repeats. So basically, a loop is a group of statements that repeat. So they keep repeating until some condition is met, and then they break out of the loop. So the same group of statements will execute, and then they will repeat and execute again, and repeat and execute again. For example, I have a cout, hello, cout, world, cout, number, cout, uh, number one, for example. So if I put these in a loop, then I'm gonna see on the screen, hello world number one. Let's say this is I or X. I. And then I change this value every iteration. So on the screen, if these are inside a loop, I would see hello world number 1, and then hello world number 2, hello world number 3, hello world number 4. So a group of statements that repeat. They keep executing over and over again. There are many um, uses and needs for a loop. Anytime you need to keep something going without rewriting the code. Um, and there are a lot of code and services and applications that you see in front of you that are within a loop. For example, the clock. The clock is inside a loop and it keeps going, going and going. Um, uh, so the book gives good examples. I'm hoping you read before you're watching, since reading before watching will help you uh, um, understand. So the first kind of loops, there are three types or kinds. You have the while loop, you have a do while loop, and then you have a for loop. The key difference is, of course, we're gonna speak in details uh, for each, and we're gonna show an example for each. The idea here, a while loop keeps executing while something is valid, while a condition is valid. It takes a Boolean, and while that Boolean is true, it keeps executing. So while some condition that evaluates to true, it keeps going. Once this condition evaluates to false, then the loop stops executing. Here in the while loop, when we reach the while loop, of course, it's gonna be part of the code. The code will be executing from top to bottom, and then we're gonna reach while loop. In a while loop, the expression gets checked first, and if it is true, then we execute and we repeat. Once this is done executing, then we go back again to the condition. Hey, are you still true? If it's still true, then we execute again. Then we go back. In the case of do while loop, in a do while loop, when we reach in a do while loop, when we reach the loop, it execute first and then it checks the condition. If the condition is true, then it executes again. So the key difference between while and do while is while will check first, do while will execute first. So the do while, whether the condition is true, they both take a condition, a Boolean condition. So even if the condition initially is false, do while will execute. So do while will execute at least once. If you have a do while loop inside your code, it will execute at least once. In a while loop, it will execute at least 0, because if we reach the loop and the condition is already false initially, then it will execute 0 times. But do while, whether it's true or false, it will at least execute once. I'm gonna give you example. For the for loop is not a true kind of condition, it's a counter loop. So it's a counter loop for example, 10 times, or for 20 times, or for 30 times. I need you to execute 20 times or 10 times. So it's a range-based loop. per se. It's a counter-controlled loop. And we're gonna see an example. Now let's try with the while loop. For the while loop, with the while loop, this is not very cool. Let me zoom in. So with the while loop, with the while loop, the format is basically while, small letter, because C++ is case sensitive. Then you're gonna give it an expression. You're gonna have either a single statement and you don't require a curly braces, similar to the if statement. If it's only one statement, then you don't need the curly braces, or multiple statements. So you're gonna have a curly braces. I like curly braces even if it's one statement. So here I'm gonna say statement, statement, statement one, statement two, statement three, etc. So this is the format or the form. There will be an expression, and the expression, as you saw in an if statement or relational operators or logical operators, whatever the expression is, it will at the end of the day evaluate some Boolean. It's going to become either true or false, either 0 or 1. So if it's true, then statement 1, 2, 3, etc. will execute. Once we are done executing, we will come back to that expression. Hey, expression, are you still true? We're going to re-evaluate. If it's still true, then we're going to go statement 1, 2, 3. Notice that these statements, one of them might trigger the expression. One of them might modify the expression. So we might execute once, twice, thrice, and on the fourth time, some statement will change the expression. So now the expression, when we come back to it and reevaluate, it will no longer become true. It will now become false. So now we break out of the loop. So while the condition is true, we execute. Once the condition is no longer true, then we will break out. It might be the user. The user might say, well, exit. So for example, um, mm, 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 we're gonna say we have an integer equals L user or called L user input. Or before the user thing, I'm just gonna follow the book because it's simpler. Maybe for some students it's better to follow what's in the book as basic as is, and then we escalate. So int number equals 0. Then my loop would be while number less than 5, for example. In this case, I need you to display hello world number, for example. This will show me what's the current value of number. And after I execute this, I'm going to say number plus plus. I'm going to increment it. Here, I'm going to just display that is it. That's all. So let's execute. So notice we started by number equals to 0. We initialized number equals to 0. And then I said while number is less than 5. So this here is an expression. And since it's a relational operator, it will eventually uh, evaluate to a Boolean. So in this case, number is number less than 5? In this case, yes, it is number less than 5 because number at this point, at the first iteration, once I reach my loop, number is equals to 0. So this will evaluate to true. The fact that this evaluated to true, it will enter the loop. We will see out hello world number 0 because at this point, number is equal to 0. And then we increment. So now number becomes 1. Now that we finished the body of the while loop, the control will come back to the condition and it will check again. Hey, is number less than 5? In this case, number equals to 1 and it is, yes, less than 5. So it will execute again. It will keep executing, it will keep repeating these statements until this expression becomes false. So notice the last time we display was when number was 4. So here number was 4. We came to this statement, we incremented. Now number becomes 5. So we come and visit the expression again and we reevaluate. Is 5 less than 5? False. It's no longer true. So it will break out of the loop and it will display that is all. So notice when number becomes 5, we don't see hello world because the body of the loop did not execute. So that's the idea behind while loop. The key or the difference is, or in this case, the special about a while loop, it is a pre-test loop. So when we first reach the while loop, we do the test first, and based on the test, we either execute or not. So it's a pre-test loop. You need to remember this. While loops are pre-test loops. So while loops are pre-test. They test first and then execute. So at least 0 times. They execute at least 0 times. Because they are pre-test. If the expression is false, they never execute. For example, number equals 10. This will never execute. See? Never execute. I don't see hello world because I visited the loop, I evaluated the condition, and the condition was false. So the loop tested first. It tested the expression first and found out that it's false. So it didn't execute. It jumped over the loop. So while loops are pre-test loops. Notice you might have an infinite loop. You might have an infinite loop sometimes on purpose, sometimes by mistake. For example, let's say I have, back to this example, let's say I have this and I have 50,000 statements inside my loop and I forgot to trigger my number. In this case, I'm going to have an infinite loop. See, it will keep going. My program is running now. Running, infinite loop forever. It will keep running because number is always 0. So the expression is always true. Every time it revisits this expression, it's gonna find that number is equals to 0 still, and the expression will evaluate to true. So this is an infinite loop, and it will get my program in a halt state or in a crazy state. You need to be careful. Sometimes it is an infinite loop on purpose. For example, looking for a network, right? Your phone, your mobile phone, if you lose coverage, whether it's 4G or Wi-Fi, there is a loop inside your phone that is infinitely looking for a new tower or a new coverage. Notice this blinking here for the text. It will blink forever. So there's a loop that is an infinite loop and it will blink infinitely. So infinite loops might be useful. You might do them on purpose and they might be dangerous. You might do them by mistake. A good use, now this is an example. A good use or the most used um, cases for while loop is to basically validate something. You want to validate while this is valid, or basically while it's invalid, try to fix it. While invalid, try again. For example, if I'm asking the user for a grade, test grade, right? A- the user while grade less than 0. So here I'm gonna say C out, enter the grade, Cn into grade. So here, C out, please re-enter a valid grade. Cn grade. Got it, finally. So basically, here I'm validating grade. I'm asking the user for a test grade. A test grade cannot be negative. You or I or any student or any person cannot score negative on a test. The minimum you will score on a test is 0, and the maximum is the full grade. So grades, valid grades, are from 0 to 10 or 100 or whatever the maximum is. So here I'm gonna ask the user for a grade. If the user enters an invalid grade, then I'm gonna say please re-enter a valid grade. As long as the user is entering invalid grade, I entered the wrong value. I entered the one negative. So as long as the user is entering a negative value, in this case an invalid grade, the program will keep running, will keep looping. Once I enter a valid grade, for example, 85 out of 10, enter, then got it finally. So I'm validating the input. The input is invalid and I'm validating it. I'm making sure it's a valid input. For example, um, Boolean, Boolean is connected, right? Equals false. So I have some component in my code that is not connected to the server. So I can say while is connected equals false, right? Or this is equivalent to saying this. While is connected false. While it's not connected, here I'm gonna say something about try connect again. If succeeded, set is connected to true. Else repeat, meaning do nothing here. Because once it comes back, set is gonna stay false because we didn't. So if else, right? If else, either this will execute or this will execute. Do nothing, so I'm gonna remove it. So try connect again. If succeeded, set connect to true. So I will end. If failed, if the reconnect failed, meaning is connected will stay false. So we will come back here and we're gonna see that is connected is still false. So I'm gonna say see out reconnecting. Right? Reconnecting. Notice when I run reconnecting, reconnecting, reconnecting. I don't have any code that actually reconnects. Assume we have a code and it succeeded in connecting. So set is connected to true. So I'm gonna set is connected equals to true. So now if I run, notice reconnecting, assuming we have a code that it did actually connect, we succeeded in connecting, I set is connected to true, so now it comes back. Is connected false? No, is connected is true. So it will break out of the loop and say, got it, finally. So, so I'm validating the connection. Next thing you need to know about is the do while loop. So in case of the do while loop, the expression, actually the format, so in the case of do while, first thing you need to know is it's postfix, post test, sorry, post test. So earlier you saw a pretest. Pretest means the control of the program will reach a while loop. The test of the loop will get checked first, and based on the result, it either executes the loop body or not. In the case of the do while, notice from the name, it will do first and then check the condition. So do first and then check while. The format is do, curly braces, curly or parentheses, and then while, parentheses, expression, semicolon. And here you're gonna have statement 1, statement 2, statement 3. So when the control reaches the a do while loop, it will first execute statements 1, 2, 3, and then it will check the expression. If this is true, it will repeat. As long as this is true, it will repeat. Once this becomes false, it breaks out of the loop and continues with the rest of the program. So the concept of a do while loop is that it's a post test loop, which means its expression is tested after each iteration. At least one. Do while loop will execute at least once. A good example for a do while loop is a menu based programs. For example, notice in this program that I'm about to write, I'm gonna say do following the form while user input is not 0. So int user input. I have some variable called user input, and here I'm gonna say cout welcome. Please pick an option. Cout enter 1 for um, mm, adding. Enter 2 for subtracting, enter 3 for division, enter 4 for multiplication, enter 5 for modulo, enter 0 to exit. This is just a simple basic example. So 1, 2, 3, 4, 5. Adding, subtracting, dividing, multiplying, modulo. So the user is gonna enter something, cin user input, and then I'm gonna say switch. Remember the switch? Switch user input. Case 1, break. Case 2, break. 3, 4. So case 3, 4. Here, see out, you entered, you are adding. You are subtracting. You are dividing, you are multiplying. So subtracting, dividing, multiplying. We missed one more. You are modeling. So notice, I'm gonna run with the F10 key. Access is denied. Oh, what did we do? We didn't do much, really. Clean, run. So, sorry, I'm gonna run with F10. So notice, when I reached the loop, it executes right away. Whether my input is 0 or not 0, it didn't even check. Notice my user input is junk value. It's still like no value at all. So it will execute at least once. And it's gonna say, welcome, please pick an option. This, and now it will wait for my user input. So for example, I'm gonna say 0. So notice, switch on this. There is no case for the 0. So it will reach the expression now. User input equals to 0. So while user input is not equal to 0, in this case, this evaluates to false. So it will not repeat the loop. It will break out of the loop. So 0, it's gonna exit. Otherwise, if I hit 1, for example, it's gonna say, you are adding, and then it will repeat. I'm gonna say 2, it will repeat. 3, it will repeat. So as long as or while user input is not 0. So as long as my input is not 0, it will keep looping. 4, 5, 4, 3, 2. As long as my input is not 0. Once I hit 0, it exits. So that's an example for a do while loop. Anytime you need a loop to execute at least once, you are going to need to use a do while loop. The next loop is the for loop. So the for loop is for performing a known number of iterations. Like here, in this case, for the while or do while, I don't know as a programmer, I don't know ahead of time how many times this loop is gonna execute, right? It depends on the user. As long as the user didn't enter 0, then it will keep executing. I don't know if the user is gonna wait for 20 iterations or 30 iterations. So in the case of for loop, for loops execute for a known number of iterations. And they have a form, specific form for them. So for loops. In the case of for loops, they are also pre-test. So similar to while loops, they might not execute at all. If the range is 0 to 0, then they will not execute. If the range is 0 to 1, then they're gonna execute once. If the range is 0 to 5, then they're gonna execute 5 times, etc. Now, 0 to 5 means from 0 as long as it's less than 5, so from 0 to 4. It might be inclusive, it might be exclusive, it might be or equal, meaning or equal or equal. So it depends on really how the programmer writes it. So for this case, we have a form. The format looks like this. So the keyword for parentheses. Then you have an initialization statement. Initialization statement and then semicolon. Then you have the test or expression, semicolon. Then you have the update, close parentheses, open curly braces, close curly braces. Of course, if you need only one statement, you don't need curly braces. I personally like it. Statement 1, for example, statement 2, statement 3. So the initialization statement, initialization statement. The initialization statement is basically declaring and initializing our counter. And most of the time, it's gonna look something like this. Int I equals to 0. This I here can be called anything. You can give it any name you want. You can call it I, you can call it your name. But most of the time, we're gonna see it as I. I stands for index. In arrays, indexes starts from 0 up until whatever the size. Let's say the size is 4. So this would be a 0, 1, 2, 3, 4. So I equals to 0 and here I equals to 4. So anytime I need to iterate this array, I will need I'm trying to remember if you guys took arrays at this point, chapter 5. Chapter 5, so arrays are chapter 6. No, function 6, then arrays and vectors. Oh, you didn't take arrays. Forget about this for now. But most of the time, the initialization statement is going to look like this, and we're going to use it this way. Then you have the expression. The expression would be I less than n, for example, whatever our target. Meaning, if I'm trying to execute 10 times, then I'm going to put I less than 10. If I'm trying to execute 20 times, then I'm going to put I less than 20. So if I starts at 0 and I need it to execute 20 times, that means I need it to go up to 19. Once it becomes 20, once I equals to 20, so I is no longer less than 20, so this expression will fail and will be evaluated to false, so it will break out of the loop. So this is where the fact that I'm starting from 0, I put my number of iterations as is here. If I want it to iterate 20 times, then I put 20, not 21, not 19. I put 20 because I'm starting from 0 and it is only less than. For example, if I have it as less than or equal, then I need to put it as, um, in this case, 19. So, so once it reaches 19, it is true. And after 19, it becomes false. So if I'm using less than and I need it to iterate 20 times, I put a 20. If I use less than or equal and I need it to iterate 20 times, then I put 19. So the standard to follow is just following less than. So be consistent. Always use less than, starting from zero for iterating arrays. Sometimes you really don't have to start from zero. Sometimes you need to start from 5. But most of the times you're gonna start from zero and be consistent in using less than and just put the number of times you need this loop to iterate. So you have the initialization, you have the expression, and then you have the update. In the update, it's an increment operator, I plus plus. So that means the update for each iteration. So when statements 1, 2, 3 execute, then the update statement gets executed. Meaning if I is at 0, it becomes I1. Then the expression gets evaluated. Let me show you an example and it will make more sense. So I'm gonna have um, let's see the example in the book. For example, the book starts from 1, just for the first example, starts from 1. It's basically trying to explain what is a loop, so min number equals 1, and then int max number equals to 10. And then the loop is for int I equals min number, I less than or equal max number. Notice the less than or equal, so they are starting from 1. Less than or equal 10, so it will execute 10 times. And then I plus plus. On each iteration, I'm going to see out iteration, number, I, and L. So in this loop, what happens is it's a pretest. So once we reach number 14, the first time we reach it, this will get executed. It will initialize I. I will become equals to 1. And then it's going to do the pretest because it's a pretest loop. It's going to say, okay, is I less than or equal max number? At this point, min number is 1. So yes, I is less than or equal number, so it will execute. Now that it's done executing, it goes to the update statement. It updates I, so now I becomes 2, and it's back to the test. It checks, executes, updates. So there is this triangle behavior that keeps happening. There is this triangle where a test gets tested, execute, update, test, execute, update, test, execute, update, text, execute, update, etc. So all the iterations, this will get executed, then this, and back to the test. This, and then back to the test. This, this. Any point where the test fails, it doesn't execute. It jumps out of the loop, breaks out of the loop. Let's execute and see it. So notice I is still nothing, junk. Now when I hit F10, it will initialize and it will test. If the test passes, it will go inside the loop, and it is the case. It will go inside. Now I is 1 because min number was 1, and it will execute. Now when I hit F10, it will come and update I. So notice, boom, now I is 2, and this was tested. The test passed, so it's true. It will iterate again. It will keep doing this until this expression fails. Notice I now at 6, I is now at 7, I is now at 8, 9, 10. Now I will become 11. So I will no longer be less than or equal max number. So it will break out of the loop. So it executed exactly 10 times. Notice if I say from 0 and less than instead of less than or equal, it will also execute 10 times from 0 to 9. So 10 times. And this will be later uh, uh, preferred because we will use I to access the array. Arrays start from 0. So we will initialize I to be equal 0 and then use I inside our body, inside our loop to actually access the array. We're going to say, okay, give me item at position I. If I is 0 means item number 1. If I is 1, then item number 2, etc. So this is for the for loop. I recommend that you practice the code, practice the exercises. Send me emails if you have any questions. I need you to practice the keeping running total. That's page 267, topic 5.7, keeping a running total using a for loop. Meaning in the body here, you're going to ask the user for an input, and then you're going to add whatever the user enters to a running total. And then at the end, once the loop is done executing, you want to display the total that the user has entered. So it's a good practice. It's a good exercise. Then we need to speak about nested loops. Nested loops are two loops inside each other. Just like if statements, you have a nested if statement. Here, if I tell this loop here to display an asterisk with a new line, notice that I'm gonna have 10 stars. Let's do it 5, just so we have it on the screen. Notice I have 5 stars. 1, 2, 3, 4, 5. Which is what I told it exactly to do. I told it run for 5 times and on each iteration display star and line. Now notice if I add a new loop, which is nested. And in this case, I can't use I because it's confusing. Now I is declared already in this scope. I is already declared. So I'm going to use J, and that's the basically standard. You use I, J, K. So I, J, in this case, we're going to say, okay, min number 2 as well, min number. And then I'm going to say also J less than max number. And then J plus plus. And in here, I'm going to display star. Once this is done, I'm going to display a new line. Notice I will execute quickly without stepping through the code to show you what happens. So what's happening is that this loop, the outer loop, is basically, as earlier we saw, is basically responsible for the lines. meaning responsible for the rows if you wanna imagine this as a table. Rows. And on each row, so in each iteration, because the out end line is here, so every time this loop finishes, I'm displaying a new line. So the outer loop will start. Right when it starts, this executes. What does this do? This goes from 0 to less than 5, meaning 5 times. And on each iteration, it displays this asterisk, a star, without space, without a new line. So, right when the program starts, we're going to enter the outer loop and then enter the enter loop, the inner loop, and it will start 5 times. 1, 2, 3, 4, 5. Now that the inner loop done executing, it will break out of the loop and it will display a new line. So now I become here. Oops. I become on this new line. So now the outer loop is a new iteration for the outer loop. I was 0, now I becomes 1. I becomes 1, so it will enter again and it will restart this loop all the way from the initialization all the way to less than max number. So again, 1, 2, 3, 4, 5, it's done. So the inner loop will break out and it will display a new line. So it will jump to the third line. It will keep doing this one as long as the outer loop is executing. So let's go and start it with F10. So notice I is what? I is minimum number, so it's 1. So it will execute its body because this evaluated to true. I at this point is 0. J at this point is 0. So notice this will execute 5 times. Notice J. I didn't change because I am inside the body of the loop. I'm inside the body of the outer loop, executing the inner loop. So J is changing. 3, 4. Now that it is 5, it will break out of the loop and it will display a new line. Boom. So now it's a new line. So we will come back, we will update I, and we will reevaluate. And in this case, it will be true because I is 1. So now I is 1 and J will repeat. So notice J will repeat as if like we just hit this loop for the first time. Boom, boom, boom. Now out, new line. Again, now I is 2. So this will keep repeating as long as I is evaluating to true. So as long as I is less than max number. Now I is 4. So this would be the last one. So now in this case, I will become 5. This will become false. So it will break out of the loop. Nested loops are important to access 2D arrays, anything that is 2D, anything that you have, for example, you have an array of students where each student has an array of grades, for example. So in this course, we have test 1, midterm, test 2, final, for example. For each student, we have 4 tests. So you can imagine it as the outer loop is iterating students, and the inner loop is iterating tests for current student. So if the outer loop is iterating students, that means when I enter the loop body here, I am at student number 1, for example, or student number 2, or student number 5. So at student number 5, I will iterate tests for that student, starting from test number 1 up to maximum number of tests. So inside here, I will have access to current student, current test. On the next iteration, the student will not change, but the test will change. And here I will have a access for current student, whatever student number I would be on. So there are a lot of uses for nested loops. The next topic is using files. Now, this chapter has loops and files in it. They are not directly related, they are indirectly related, just like any other topic in C++, but it happens that they have them in one um, chapter. So I'm going to take these off. I'm going to come to the whiteboard. I'm going to type four important steps when you are working with files. First, what are files? Files are a way for when a program needs to save data for later use. So it writes the data in a file. The data can be then read from the file at a later time. Meaning, imagine when you close your application. When you close an application and then excuse me. When you close an application and restart your application, it restarts back where you left off. Meaning, when you close your application, those data got saved somewhere. And then when you restarted your application, the data that you left off with got loaded or reloaded, and then you continue where you left off. Most of the times, those data are stored in files, and there are a lot of types of files. You have a text file, you have a document file, you have a PDF, you have a binary file, you have a data file, you have a lot of files. In this case, we're going to work with text files. Text extension. So file.text. There are four important steps when working with files. First, you need to open the file. Second, you need to check if the file was opened successfully. Then you need to process the file, whatever the task you're trying to do. And finally, you need to close the file. Of course, you can't work with a file without opening the file. We can't work with the file, you can't finish the task without processing the file. You can't process the file if it wasn't opened successfully. And finally, closing the file. Each of these steps is as important as the other. As important as opening the file is closing the file. And that's for several reasons. Later, you're gonna know, or maybe you know by now, sometimes you try to click on a file and it tells you, I can't open the file, it's being used by another program. So if your program opens a file and never closes this file, then your program has a hold on that file. The operating system will not allow any other processes to access that file because your program opened the file. Sometimes you are running multiple threads and it's called multi-threading, meaning your program is running multiple threads. So you might have a thread accessing the file at one point and another thread accessing the same file at another point. So your program tries to access that file and the file will not be accessible. It will say access denied because the previous thread did not close the file. It opened the file, it processed the file, and it didn't close the file. So now this process or this thread has a hold on that file. So when the second time your program tries to access the file, it gets access denied and it crashes. It crashes your program. So long story short for now, anytime you open the file, you need to close it. And closing it is as important as any other steps. You have a task, right? You have a task you need to work on a file. You need to load from a file or write to the file. Whatever the task is, once you're done with the task, close the file. As simple as that. So now we're gonna go in uh, code, and then we're gonna do the syntax for each of these steps. So the book has a lot of info, and I recommend that you read them, and you should read them. Then they speak about types of files. They speak about the file access methods. Then they speak about file names and file stream objects. Then they start speaking about setting your program for file input and output. And basically, it's telling you that anytime you need to work with files, similar to including input and output stream, you need to include F stream, file stream. This library allows you to work with files. Then it tells you that first you need to open the file, right? I'm gonna type the steps here. Right? These are the steps. For example, process the file. In this case, I'm going to read an integer from a file. That's the task, right? This is the task that I need. I need to read an integer from a file. There is a file that has one integer in it, and I need to read it. I need to read that integer from the file into my program. So the book tells you that first you need an object that is responsible for working with files, similar to cout, for example. Cout is responsible to display on the screen. So in this case, you need an if stream. Why if stream? So if stream provides you input and output. In this case, the task is to read from the file. So I need an in file stream. So input file stream. So I'm going to say this is the data type, and here I'm going to say my file. This is the object that I'm going to work with. So open the file. I'm going to say L my file dot allows me to see all the options or functions that this object provides. So I'm going to type open, and then it takes an input. It expects the file name that you are trying to open. In this case, I'm going to open a file called test.txt. Here you need to know something. My file, I'm telling this object that is brand new, it doesn't know anything. I'm telling it, hey, there is a file called test.txt, and I need you to open it. So where is test.txt really? The fact that I did not give it a path, I just gave it the file name, this means the program expects the file to be where the program is, meaning where I created my project. If I go to my source file, and this is called main in your case, I think, here it's called console application, I can right click and I can say, um, so it's not showing it to me here. Let's try at the project level, like at the project, this is the project, this is the file, this is project, this is solution. So at the project level, here it is, open folder in File Explorer. As a matter of fact, if I click here, yeah, here, open containing folder. So I can open whatever the folder. See, if I hover my mouse, it tells me. It lives in C, users, Khalil, documents, Visual Studio 2, blah, 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 blah. So this is where my program lives. I'm going to say open containing folder. So this is where my program lives. So the fact that I did not give it a path, then my file object will try to look in this directory. If it found the file, it will open the file. If it didn't find the file, then it will not open. It will not be able to open the file. So now I'm going to say text test.text. And inside it, I'm going to put, for example, the number 10. I'm going to click X. It's going to ask me to save. I'm going to say save. I'm going to minimize this. So back to this. If I did not specify a path, then this is where it's trying to look. Or I can specify exactly by telling it C users, for example, me, desktop, test. And remember the escape sequence. So now the fact that I gave it a complete path, it will go ahead and look in C drive, users, me, my desktop, on the desktop. So back to as is. This is what I needed to check. Then I'm gonna, maybe at this point it's easier to tell you that I can al my file, say al my file dot close, as simple as this. So this is how I open a file and then I close the file. So I'm left out with two steps. First one is to check if the file was opened successfully. And the second step is to process the file. There are multiple ways to check if a file was opened successfully. First one is checking with the if statement, of course, if l my file dot is open. This is one way. So here, if is open is true, then I can go ahead and process. So curly braces. Eventually, only if it was opened, I will close it. If this didn't succeed, then there is no need to call this function outside the if statement. Interesting that the book starts speaking about writing without checking if it was open. Anyway, this is one way. Another way is by just checking this variable. Because if all my file did not open successfully, then this becomes null. So if null is equivalent to not true, because null is not a true. Null is 0. It's not the value true. So if null, if this becomes, this will evaluate to null. And the fact that if statement is taking null, meaning it will evaluate to false, so it will not execute. Another one is by checking fail. Yep, fail. So here, if fail equals false, if fail equals false, then I need to process. So there are multiple ways for you really to check as long as you check. Now I need to read from the file. Similar to the way you read from the screen. And from reading the screen, you say cin into my integer, for example. So let's declare integer my integer. So the same way you read from the screen, but this time from the file. So the arrow is from the file arrow to the integer. So now I read the integer, I did the task, I will close the file, and here I will just display the integer. This way I see it on the screen. So let's execute. I should see 10. Here it is, 10. So this code, if you step through this code, you're gonna see that everything will work as expected, and then it will display integer. I can read with a loop up until I detect the end of my file. For example, I have 5 lines. Sometimes I need to read from a file and I don't know how many lines are in the file. If you know the structure of the file, in this case, I know the structure of the file. I know that there is an integer on each line. If you know the structure of the file, what you can see, what you can do is you can use this as your condition in the while loop. So you're gonna say these will stay the same, right? Fail, blah, blah, blah. The process will change. Here I'm gonna read each integer and then display each integer on the screen. So I'm gonna read it from the file, display to the screen. That's the process. Read all integers from a file, then display them. So read and display basically. Read and display all integers from a file. This is the task. So what I can do is I can say while this condition cout L my integer. So here basically what I'm saying, while this is true or while this is valid, because this operator, if this operator fails, it will return null, and null is gonna be evaluated to false, so it will break out of the loop. And this operator will fail once I reach the end of the file. Once I reach the end of the file, this operator will fail. So this means this will keep executing as long as it's reading. And remember, this operator will stop reading on the space character or the new line character. So when I reach this line, it will read from all my file to my integer anything up until the new line, meaning 10. Then the fact that this returned true and populated my integer, I will be able to display my integer. And then it will repeat. Now it will read everything up until the new line, put it in my integer and evaluate to true. And it will repeat. So let's execute. Here it is, 10, 20, 30, 40, 50. Once it reaches the end of the file, this failed, so it evaluated to false, and it broke out of the loop. Another way is, for example, let's say I don't know the structure. I don't know the structure of my file. Maybe it will still work with um, with this simple example, because this operator will stop. In future, I will show you a different example where this doesn't work. For example, let's say these are courses. Some students so far have 5 courses, already took 5. Some students already took 4. Some students already took 3. So I cannot say while um, course 1, course 2, course 3, course 4, because I don't know. A student would have only course 1. They wouldn't have course 2, course 3, course 4. So this logic will not work. And I will need a different approach, which is similar to saying while l my file dot end of file. This end of file will return true if it is the end of file. So what I'm gonna say, while end of file is false, meaning while I did not reach the end of file, I need you to read to my integer. This is equivalent to saying exclamation end of file. So while my file end of file is not true. Let's try again. Here it is. So 10, 20. Once it reached the end of the file, this evaluated to false, so it will broke out of the loop. It closed the file and everybody is happy. This is for reading from a file. Writing to a file, you don't need EOF for writing to the file. You don't need to detect the end of the file. Eventually, theoretically, you're limited by the computer memory, but there is no end of file. You can keep writing to the file as long as you want. So the while in the right case, the while would be based on your logic. How many times do you want to write? For example, while I still have students, while the user still needs me to write, or a for loop. I have 10 students, so for 10 times, write. For 10 times, for 20 times, do. Um, the difference with write is instead of I, it will become O. There is an example, but writing this would be like the harder part because you need to check if the file was opened successfully and you need this condition to read from the file. You can't read infinitely. In the output file, in the output way, when you are trying to write to a file, first you don't need to check if the file was opened successfully. Why? Because the open, if it doesn't find the file, it will create the file. So whether the file is there or not, you're not gonna have any issues. Here, if the file in the read part, if the file doesn't exist and you try to read, you crash the program because you're trying to read from a file that doesn't exist. But in the off stream way, first you tell it to open and you give it the name. If the file is there, it will replace it. It will delete it and meaning override it. So whatever you write to that file, you're gonna lose everything old. So if the file was there, it will override it, overwrite it. If the file is not there, it will create it for you. And then you're not gonna use end of file, you're gonna use your own logic. If the, for example, if the user keeps asking you to write a new line, then that's your condition. There is a good example in the book. I need you to practice. And there is an example in the book for letting the user enter file name, which should be easy for you. So basically, you're gonna get line from the user into a string variable. And instead of giving literal here, you're gonna give it the variable, the string variable. I need you to practice these. And let me know if you have any questions.